Okay, so we're looking at a crate. We've got a mass of 500 kilograms. It's on rough horizontal ground, so we know there's friction involved. A force of 2,500 newtons. And we're looking for mu, or the coefficient of friction. So we write out our little bits and pieces. And we have our formula, which is that friction is equal to mu r. So let's draw our little diagram now. So again, mu is the measurement of roughness between an object and a surface. So mg, so 500 g, or 5,000 if you want to put that in. R, which is our contact force. We have a constant, a force of 2,500 newtons, and then our frictional force in the opposite direction. So from there we can figure this out. This is question 1 on a paper from 2019. So you can tell it's the first question. It's not too expansive. It's 3 marks, and it's 2 steps basically. So 2,500 is our force. Take away the friction, which is mu r in this case, and is equal to 0. And just plug in those values basically. So, I mean, there's not really much to this at all. So mu is equal to a half, it looks like, yeah, 0.5. And that's that first question. Here we're looking at a crate, again, mass 300 kilograms on a rough ground, so we have friction. The coefficient of friction, of course, is given there, and mu 0.5. Force of magnitude of xn, which we have to find as an angle above the horizontal. Keep note of those ideas. And sine alpha, in this case, is 0.28. Find its greatest value when it remains at rest. Okay. So start up and fix up our little diagram here. And put little details to the right hand side, like mu is equal to 0.5. Just leave that there for a moment. And we may even put in your little formulas and things if you wish, like F equals mu r. Maybe even write that in. So you're looking for r perhaps initially. It just depends on what you've been given. We also were given a sine value. So if you're given any trig values like sine, cosine, tan, go off again to a little part on the side and find the inverse, find a value for it. Draw a triangle if you need to. Maybe you don't need it, but if you were given, this is a decimal, but let's say you were given 7 over 24 or some kind of fraction, you might have to find tan or cosine. So you obviously use sine and cosine components in mechanics, so they'll be more likely, but you could indeed be given a tan value as well, so just be careful with that. So our sine value is there. We've put down already the ideas for our diagram, and we're going to look at the y-axis now. So r plus the sine component on our actual force for x is equal to, or minus 300g. So x sine 0.28 minus 300g from there you can find your x. Now we put in our x, again, x-axis. I'm just doing here. I'll change my colors and I'll change a few bits and pieces here and there with this kind of conventions that I do, but it should be straightforward. I highlight basically the ideas, and you can see that the color coordination is relevant. So we have our sine and cosine there, just to plug them in. You can put in the sine 0.28, or you can put in the 16.26. Always, you can check these things as well, just to make it, clarify it as well for yourself. 0.96x, so minus 0.5 is a mu, or, and we were given or, you can just rearrange what you had up on the first equation to find r. So r is equal to 300g minus x sine 16.226, or again 0.28. Have a quick look at that yourself if you want. That aspect in brackets is just r substituted in. So 1500 plus 0.14x. So bring your x's together, you'll get 1500 divided by 1.1. X is equal to 1,363 point dot dot dot. You obviously round these things to whatever specification you want. In your exams, you'll know this anyway. So 3 significant figures or whatever it might ask. It may ask you to do it in certain decimal places. So 1360. Okay, we're looking at a mass of 3 kilograms for a block, inclined at 60 degrees on a rough plane. Force is 15 newtons up a line. And we're going to prevent the block from sliding down. These kind of details will be relevant when we get to it. So when you're preventing a block from sliding down the plane, as it says, you might want to just keep in mind about what the intention is. So the block intends to move down. So your like mu r or f would be going up, and there's little aspects like that might come into this question. We'll see. The first thing we need to do is find the coefficient of friction. So find mu r. So put in our angles and our forces onto our diagram first of all. And we have r as well. It's like the magnitude of the normal reaction between the block itself and the surface of the plane. And that's a part of the formula for finding friction. And remember, if the surface was smooth, there wouldn't be any friction. So when mu is greater than 0, you've got what's called a rough surface. So I've said already, preventing the block from sliding down is probably an aspect. I can see that now in the second part, because it does not move. The block does not move. Before we get there, I think that's set up now, the diagram. So you can see that mu r is going up. I've just told you in a way that you need to think about where it's intending to go. So it's intending to slide down, and that's why that happens. Okay, looking at parallel. So our component of 3g sine 60 minus the 15, so I'm just doing it that way, minus mu, then the component for r is 3g cosine 60. This is all equal to 0. Of course, 3g cosine 60 is the value for r. That's the component there going down as well. So perpendicular, I mean. And of course, on your exam, you can write these more clearly, more easily. 3g sine 60 is 30. 3g is 30. Sine 60 is root 3 over 2. You would know that already, presumably. Of course, you have your calculator too. So I'm just writing in there. The normal reaction is 15 newtons. From there, you can find mu. So 3g sine 60 minus 15 divided by 15. And the 15, of course, is 3g cosine 60. So mu is equal to 0.732. That's our first part complete. Okay, next part, find the greatest value for x. So the maximum value. So initially we had mu r going up the plane. And we're going to see if the block does not move. So again, think about the intention of the block. I don't mean the block itself has, has the ability to comprehend, but I mean just where it will be going. So in this case, we're going to move our mu r. It'll be going down the plane, down the incline, down the slope. And we remove the 15 newtons. And we again just have x for that. Find the graded value of that force when the block does not move. Occasionally with these questions, it requires a little bit of silent thinking. Just stop doing the questions, think about what's happening, even read up a bit more about friction and about these aspects. And just the reality of them, perhaps. Even though we have modeling assumptions in these questions, thinking about just the ideas involved, thinking a little bit deeply about these small details. Okay, part 2, our force X max is equal to mu r plus the component of the sine going down, so 30 sine 60, or 3g sine 60. Got a value of 37. Okay, question 6. So we know that this question is actually going to be towards the end of the paper. There's 7 questions on the mechanics paper. So I'll underline my aspects here. As a force, as our mg, gives us a cosine theta value. Also gives us some suvat aspects. We have time involved and distance. And I've already pre-drawn the diagram there just to make it a bit quicker. So cosine 24 over 25, you could leave it at that if you want. You know, your force times 24 over 25, or you can find that inverse value there on your calculator. Sometimes you'd have to find the sine or cosine value. So again, draw a triangle if you need to use your trig values. Sometimes you're given tan even. From there you'd find the hypotenuse perhaps, and you'd find cosine and sine values. Okay, show the coefficient after finding the frictional force. You're given mu, so you have to find that in its own way. And then the last question we leave for a second. So we're given a period of 5 seconds and the block moves a distance of 4.5 meters. So S is 4.5 for S, sorry. Our initial velocity is 0. And as I said, time is 5. So pick your equation of constant acceleration there. S equals ut plus half at squared. We're looking for acceleration. And we got it. Okay. So 0.36 meters per second. Then we can use F equals ma. So we'll do our x-axis. So the component for this is 6 cosine 16.3 minus your friction, just look at the diagram if you need to, is equal to 3 times your acceleration. So 3 times 0.36. So your frictional force, FR if you want, is equal to 5.76 minus 1.08 is 4.68 newtons. That's part 1. So have a think back about what we just did there. We've pursued that, we found acceleration, and then we were able to use that to find our frictional force. And we also have F equals mu r, which could be involved in the first part as well if you've been looking at it in a certain way. But we were given it details that looks more likely to use suvat in that way. R is equal to 3g minus, again, the sine component, so 6 sine 16.3 is equal to 28.32. 28.3 is fine. Plug that into your formula. F equals mu, which is given to us already, 0.165. Let me just think about that for a second. We actually can't just use that yet though, so plug in your values to prove it. So 4.68 equals mu times 28.32, and when you just divide 28 by 4, you'll get that. You'll get the value of mu. Okay, that's our second part done. Third part, when the block is moved a distance, force is removed and the block then decelerates. So we know that acceleration will be minus or negative. Find the total time. So we already had 5 seconds, a period of 5 seconds that was applied when the block moved 4.5 meters. You'll see that on your initial paragraph. And then there's something else that happens as well. So when the block is moved, the force is removed. That rhymes, unintentional. Okay. We're going to use SUVAT again. I think if you think about it here, we may have two different ideas there. So let's start off. When it moves 4.5 meters, then the force is removed and it decelerates. Okay, let's put in S is 4.5. So initially, of course, we've U is equal to 0. Just previously, we've had this already. If you look to the right-hand side, we have 4.5 for displacement. U, initial velocity is 0. Acceleration, in this case, is 0.36, and our time was 5. So the only thing new here was the acceleration, which we got previously. Okay. Find your velocity. And it involves, we have time, but we don't have to use, we can still use v squared equals u squared plus 2as. So 0 for u, and make sure you square it. Find the square root of that answer. So 2 times 0.36 times 4.5, and the root of that is 1.8 meters per second. So when it moves 4.5 meters now, when it's moved, so we have a new initial velocity of 1.8. That's one thing that often happens in these questions when you do two stages of motion. Your final velocity from previous stage is now your initial velocity. Our velocity is 0. It comes to rest. It completes its journey. Acceleration we're going to have to find. We know that acceleration changes, it decelerates, and time is what we need overall. So our acceleration is what we're going to find here. It should be minus something. So going back to our block, mu r equals ma. The force involved was mu r, which was 4.95 equals 3a. So a is minus 1.65 meters per second per second. I'm going to jump back over our triptych here. Got 3 little bits. We've one last bit to do. We have our acceleration. We know that's decelerating now. We have to find the total time. So again, which of your equations of constant acceleration that involve time will you pick here? The easiest one is v equals u plus at, so 0 equals 1.8 plus or minus, but minus will win, minus 1.65 t. T is equal to 1.0909, so we'll just go with 1.09. And of course, I already stated that we had motion before from the first initial description in the question of 5 seconds. So the force applied for a period of 5 seconds. And so we add them up to find our total time. So the total time is 5 and 1.09, which is 6.09. That was quite an expansive question, but that again was the second last question on that paper. On to our last question. So from 2019, we have a particle of mass 13 kilograms on a rough plane. We've got an angle to the horizontal. We're given here a tan data of value of 5/12. You can start off by just figuring that out. Of course, you can always use your calculator, but you can use a triangle as well to help with the trig values if you have to find sine and cosine values. And that aspect of that, so do it separately on the little panel there on the right hand side. We're given mu 0.3, which is the coefficient of friction, forces T and moves a particle. So we're also given some suvat detail, a distance of 2.5. It'll make you think it's suvat, we will see. And the last part of the paragraph states, find the work done. So I'm going to draw my diagram here before I get to that. So put in all your aspects, your different forces. Acting parallel to the line of greatest slope moves a particle distance up the plane. So just keep note of those aspects, of course. T is going up the plane and friction is in the opposite direction. And we can get started then. So we'll resolve our components parallel and perpendicular. So the y-axis there, r is equal to 13g cosine 22.62 if you want. So r is equal to 120. And then our x-axis, or t, how will we do this? We can use f. First of all, I might just do f is friction. F, or friction is 0.3 times 120, which is 36. So F equals mu r is our calculation there. And then, of course, just following that, I'll find T. So T is equal to that 36. 0.1, so 36. Good man, Thomas. 36 plus 13g, or 13g sine 22.6. So 130 times sine 22.6. So T is equal to 86 newtons. And that's as far as Unit 4 takes us with friction, as you probably know. So the final part of this question is to do with work done, which you haven't probably done yet, but just to introduce an idea just before we move on. So Unit 8 actually has this. So if you study science, you might know it, but if you don't, it's okay too. You can skip it if you want. But this part of this question has an extra element from a different unit that you may not have done yet if we're doing them in the normal way. So force times distance is work done. So our 86, our force of 86 newtons times that distance that was given is the final answer. That's 215 joules.